Hello everyone, welcome to another tutorial on ROS. Previously we saw how different blocks of code in ROS communicate with each other through nodes and topics. Nodes are blocks of code that can publish or subscribe to a topic. And I said there is another type of communication, service and client, which node sends command to a service and asks for something, gets a response. Not going to go through details of service client. If you want, you can check the ROS wiki page tutorials on how to create a service client communication. It's very straightforward, similar to uh, publisher subscriber, the way nodes and topics talk. Today I'm gonna show how we can create a package, how we can create these nodes, and how we can create a topic and ask a node to send code to a topic, send command to a topic, or subscribe and receive data from the topic. In the assignments and in the project and in the lab tutorials, you're not asked to create a package. We usually give you the already created a package and you have to modify the codes. But it's essentially important to know how you can create a package and then how you can modify the Python codes, which you need to do in the lab and in your project. And so let's begin. Something that I haven't mentioned is ROS launch. So far, when we wanted to run nodes, Python code, executable Python code that we call them nodes, we had to run them separately using ROS run command. When you're building a massive package, when lots of codes need to interact with each other, there is no point to running these nodes separately and independently run each node using a command. We can write a launch file that will run all the nodes that we want together. I will show you how to create a launch file today as well. And now let's begin creating a simple package, the package that we used in the previous tutorial. I want to create a package that has two nodes, one sending data to a topic and the other is capable of subscribing and retrieving that data. I need two Python codes, very simple codes. If you remember, we created a Catkin workspace where all our codes are inside this workspace. And I copied a package called tutorial here and used it. I'm going to delete it and create it together from scratch. Let's open up a terminal. Package in ROS, we use the catkin create package command. Catkin underscore create package. And then we need to give a name to that package. I call it tutorial. And finally, you need to define dependencies. Every package will depend on some other libraries and packages. And there are three main packages that we need to have. One is called std messages. This is a package that includes different type of message. Previously, I mentioned that we have different types of messages: float, integer, even images. These are all included in this package. So whatever package we build will depend on this. And the other one is ROS.py and ROS.C++. You need these two as well if you want to code in Python or C++. If you're building a huge package that depends on other libraries, you could include them here. For instance, there is an existing library for using a specific piece of hardware. If you want to create a package, you can include that and then use it later. So this is where we define dependencies. For now, these three are enough for most applications. Even if you want to code in Python, it's better to include the CPP library as well, because there are some codes that have a wrapper around C++ code. So we keep these three always inside our packages. And one thing to notice, I'm creating this inside my Catkin workspace. If I look at my Catkin workspace, there are 3 folders in it: build, development, source. We should put our packages in the source folder. And now I will create the package. Create Catkin create. Name of the package, dependencies. Now the package is created. If I go to the folder inside Catkin, my packages should be inside source file. There is a new package created tutorial. If I go, it has 2 folders already. One is source. This is where I will put my Python codes. If I want to create nodes, I will put it in here. And there is a package XML file. This is a file where you can put information from your package. There are lots of comments in there. It's basically empty. First thing, you can add your email and your name if you want other people to use this package, so they will know who developed it. If they had questions, they can come and ask. If you have a license for a package, you can put it here, website. And the dependencies that I added are also included here: ROS, CPP, Pi, and messages. If you want to add dependencies later, you could include them here. Another file is CMake list. This also shows what packages I have included inside of it: ROS, CPP, Pi, STD messages. The rest are mostly comments. This file is used in case you want to include a new type of message. ROS has lots of different types of message: float, integer, images. Some scenarios you want to create a specific type of message, or some service. When we talk about client and services, didn't get into details of it, but if you want to create a specific message, you include it here. We'll leave it empty for now. We're not gonna use any type of a specific message. All these numbers and arrows are usually enough. So I have created an empty package now. There is nothing in it, just the dependencies and empty folder. The next step for me is to create my Python files where I want to write my notes. So inside the source folder, there is now tutorial. I go to tutorial folder. Inside tutorial, there is a source folder that was empty. This is where I will store all my codes. It's usually called source src or sometimes script. Both are the same. Now I'm inside the source. I will create my first node. I want a node to publish data. And in terms of like our course in image processing, for instance, this could be a node that processes an image, captures images and processes them. It's a Python code. You can include OpenCV module here in the node and do all different sorts of image processing tasks. I would create an empty Python file. To create a file, you can use touch command. Touch name of the file. I will call it publisher node.py. I will create another one for a second node that would subscribe and receive data. We call it subscriber.py. Now in my source folder, these 2 empty ones are created. These are Python files. I can open them. They are empty. One thing I mentioned from previous session is whenever you bring a new package or whenever you create a new Python file, it must be executable. So we have to make it executable. The way we do it is using change mod. X means executable and name of it. So now ROS understand what these are. Now I'm gonna open them and start coding in them. I will use the PyCharm IDE to modify these. I already have installed PyCharm. So this is an empty file, and we can write our Python code in here. There are 5 or 6 commands that we need to define a node. Then the rest of the code could be any Python code that we want to write. The first thing is that we need to tell ROS that use Python to execute this. This is done using this command. So this command gives the address for the Python in my system to ROS. It's always in user bin environment. And I'm using Python 3. One thing to notice is that this Ubuntu Focal latest version of Ubuntu includes Python 3 already. If you're using later versions, it has Python 2, and then this command should be Python, not Python 3. So remember to give the Python address at the beginning of the code in this format. If you're using Python 2 or 3, you can change this. It could be Python for Python 2 or 3 for Python 3. The next step, I will import some of the modules I'm gonna use. One thing is, first we need ROS.py module. ROS.py enables coding in Python inside ROS environment. I already brought NumPy as well if you want to do any matrix multiplication, and we bring different message types that we want to use. I've brought from the std message module a message type called string for text, float, multi-array if you want to have arrays, or float if you want to have just numbers. I have imported several modules. This is straightforward. We had this in Python as well. Now I will create a class that could publish data to a topic. We call this class publish. First, it needs to have a function to initialize the node. So there are 3 lines of code that I put here. What do they mean? First code is using ROS.py init node. This will initialize the node for us, and it will ask for 2 inputs: the name of the node that we want to create, I call it publisher node, and also we make it anonymous. What does it mean? It means that it will assign a random number after the name of the node to make sure not 2 nodes have the same name. So this creates the node for us. This is one line. The second line is defining the topic. I want to publish data with this node. I use publisher and rospy.publisher command. Rospy.publisher creates a new topic that this node that I named publisher node will send data to it, publish data to it. It asks for 3 inputs: name of the topic, called it data, what type of data is in it, and the queue size. Queue size means how many data can stay in there. For instance, if data comes faster in it than the speed that we are retrieving data from it, it will store 10 data, and after that it will keep deleting them. And finally, we give it the rate. This is in hertz. This is the sampling time of the node. This is how fast do you want to publish to the topic. I'm giving 10 hertz, so 0.1 second. So it will publish a data onto this topic called data every 0.1 second. This is what I use to initialize the node. And then anything we want to do, we do it in a second function. This function is where we put our code, or you can have separate functions for image processing, for connecting to a camera, to a hardware, like any type of Python code. For instance, I want to create a simple data and publish it. I don't want to do anything complex. So I create a data, call it self package, and I give it what type is it. My topic, the topic that I created, is float. So the data that I want to publish on it must be float. And what is the data itself? Let's give it a number, 12. I want to send number 12 to the topic. And finally, we ask it to publish it. We're done. So I create a function that would publish a data that float, and the value for it is 12, and I ask it to publish it while ROS is operating. ROS.py is shut down, looks at the ROS core. If you remember, when we wanted to run ROS, first we had to run the ROS core, the main master node. So it says until that is not, the ROS core is not shut down, publish this data, and we use publisher.publish command. Name of the publishing node was called self.publisher, self.publisher.publish the data that I created. So publish it to the topic, and at what rate? The rate that I have previously defined. So this makes sure that at 10 Hertz we're sending this data to a topic, and topic name was data, and that is all we need. So, and finally, to run this class independently, we can use this command. If you're familiar with coding in Python, you already know what this block means. If name is equal to main, this means that if this function is called, this Python code, open up the class and run the callback function, which will publish data, unless the interruption is exists. For instance, somebody presses Control and C and interrupts it. So this last block is asking to run the class function for us. And this is all we need to create a publishing node, a node that can publish data. And usually everything you have to do is copy and paste this. You don't even need to memorize these codes. You copy and paste this and you create a publisher. Whatever you want to do goes into these functions here in the callback, or create your own function. You can, for instance, in here, read an image and then process it, find something on it, then publish that. So your code could go here. The rest of this is just to create a node that publishes data, and what type of data we defined it. Now I save this file. And then I want to create a second node, a node that would subscribe to this topic and read this data. I created a subscriber file which was executable. I open it again in PyCharm. For the subscriber, it's very similar. We have to put all these lines first. Tell it, okay, use Python, what are any module you want to import, and then creating a class similarly. So very similar to the node that publish, a node that wants to subscribe. I created a class inside, first initialize it. We have to define the node, give it a name. I call it subscriber node. It's anonymous, So if we have the same nodes somewhere else, it would give it a random number. Then we tell it which topic to look for and what type of data expect to receive using rospy.subscriber. The name of the topic was data, and the type of data is float. And for a subscriber, you can give it a callback. So in case it receives data, it can confirm that it has received it. I give it a function called callback to confirm that it has received. And then creating a callback function to get the data. So the callback function gets the data. And again, if you want to do anything with the data, you can do it here. You can get the data, it would be float 64. It's a name I give to the data that I receive. It could be anything, so I call it data. And inside of it, it's a float. Float messages have a data object in it. Inside of it is that number that we wanted. This could have been a string or anything. And I receive it here. I ask it to print I heard the data, so we know that it has received, and then you can do anything you want with the data here. Again, if you want to write any code to manipulate the data, do anything, it comes here. And finally, we ask to run it as a code if it is called. Similarly, this if loop makes sure if this code is run as if called from any ever inside ROS to open up the class and run it and get data. Remember, for publisher we gave it a frequency for sending data. Subscriber does not need any frequency. It gets the data as fast as it comes at any frequency that it receives. This code ROS by spin makes sure it's constantly running, checking for data. So whenever it receives something on the topic, it will just get it. It doesn't have to wait for a specific sampling time at a specific frequency. And now that we have created these two, let's test them, see if it works. Going back to I have to install the package first using catkin make command. I go to the catkin workspace, run the catkin make, installs all the packages. See, it found one new package, installed it. Then we have to source the setup file. If you have put this line in your terminal, every time you open it, it will automatically source the setup file, so it's fine. So I installed a new package. Now I want to test it. I run ROS core to start running ROS. Then I will open up new terminals. I will run my publisher first using ROS run. The name of the package, the executable file, which was named publisher, starts publishing. Let's see if there is a node created. ROS node list. It creates a publisher node, the name that I given it, randomized it with a number. You can see the topics. There's a topic called data that I created, and it's publishing to it. We can see what is inside the topic. ROS topic echo, name of it, sending number 12. I can now run the other node that was subscribing, getting data. it's getting data and saying I heard it. So if I look at the node list again, I have two nodes, one is sending data, one is getting. That is essentially what we want from ROS. We can communicate between different lines of code at a specific frequency we want. And all we had to do was, in these few lines of code, create a node, publish it at a specific type of data, a specific frequency, and then receive it. One thing to notice is a node can both publish and subscribe. There is no limitation. Like this publisher node can also subscribe to a different topic. The same function, I have to just initialize a new subscriber here and then have a function, another function to get data. So a node can get data from various topics and then use them, process them, run an algorithm, then publish them on several topics. So a node doesn't have to be a publisher or a subscriber. It can be both. Simply merging these two codes, you can do that. Very straightforward. Now I can show you some other examples using different types of data. For instance, let's change the type of data to string. I want to send a text. So my data is string. I have to change it in the subscriber as well. Now let's see how it changes. If I run this again and I run the node that was subscribing, it says I heard hello. That was sending a string and this received a string. We can do other things. For instance, you can also record the real time. That is some of the very nice features in ROS. It's a real-time software operator. You can get the real time and perform a task in real time. For instance, I want to get the time and plot a sinusoidal signal, let's say. In my publisher, I would initialize time. The command to get the real time is called, I create a parameter called time, and the command to get the time is called rospy.get time. This will get the real time of from the clock of the CPU. And let's change our data type back to float. And then I want to print time, let's say, for instance. I will get the time and subtract it from the initial time. That would be my data. And then so the data type should also float. So I'm getting initializing the time, getting the real time, and then in my function subtract it from the time again, initial time subtracted from actual time to get the what is exactly the time since I begin running the code. One thing is that when you're reading the time, it should be done at the same time as we update ROS rate. So we put it inside this loop. This ROS the rate function, rospy.rate, is actually the code that is enforcing the real timeness. So now I'm reading the time and I want to publish it, and my subscriber will say receive the time and say okay, the time is this. Let's run this. Publishing the time on the topic, subscribing to it. So this is counting the time now. can also, for instance, find the cosine of with respect to time. I put it in a numpy array. Just want to show that you can do anything here in the code and even play with the real time, some of the features that you don't really have access when you're using coding with Python or C++ in an environment that's not real time. Syncing up the time with the CPU clock is very challenging. ROS gives us this interesting feature. And so now let's sign off this function. Let's publish this again. And you see we're getting a sign value changing between 1 and -1. Let's open up RQT, take a look at again at our nodes and topics. I have a publisher, a subscriber, they're working on this topic. There are some features in RQT, for instance, for logging data as a bag file. So selecting the topics that we want to record, for instance, the data, and then record it. And it will ask where do you want to record it. I give it in my catkin folder, give it a name, data, and then it will start recording data, and you can stop it whenever you want. This way you can save any data and then later open it in Python or MATLAB and plot it. So you can use this RQT environment to save data. There are also commands for saving, which I showed in the slide. You can do this through the terminal as well. So let's cancel this. We can also plot them in real time as well. For instance, if we go to visualization, plot, you can select the topic that you want to plot. If it's just one number that was called data, we can plot it. If it was a multi-array, you should select which element of the array you want to plot. But let's plot the data. I select the topic that I want to plot, add it to this figure, and you can see that it's showing that sinusoidal signal that was changing. You can change the scale of your plot here. And even save the plot here as well. Change the axes, limits of the axis if you want. My x-axis, I want it from time 0. Okay. To let's say what time? It's at 65 now. Let's put 100. And my y-axis should be between, let's say, -2 and 2. And you can see the data in a bigger range. It's a sinusoidal signal. So RQT, you can visualize the data as well. One last thing I want to talk about is using launch file. As I said, you can, instead of running multiple nodes through command line, you can write a command to run all of them at the same time. And that is done through launch files. Let's start writing a launch file. I will close the ROS. Going to my catkin workspace, I'll go where my package is. It was inside source, then the name of package was tutorial. Inside of it we had 2 folders. I create a new folder called launch. Going to the folder, I create a launch file Using touch command, I create a file. Let's call it run.launch. This file now is created. For the launch, this one. So I will open it. To write a launch file is in XML format. You always have to enter this line at the beginning. This will tell it that, okay, use XML to run this file. If you're not familiar with XML coding, it's very straightforward and we don't use it that much, but just for creating a launch file, which you might never use, but it's good to know about launch files that you can just use it to run multiple nodes at the same time. We create a launch environment and we can close it. Inside here we have to tell which nodes to run. I created two groups, two nodes, one for my publisher, one more subscriber, and this is the code to run the node. You create a group and give it a name, node 1. Then inside of it you create a node environment. Give it the name. What should you call it? Whatever name you want. From which package it is. The package was called tutorial. What is the name of the file that you want to use? Executable Python file. It was publish node. It was publisher node. And then telling it where to find it. It's in my tutorial. Find my tutorial package inside the source folder. That's where the Python file is, and this will open it and run that node. Similarly for the subscriber node. Now I save this launch file. Done. If I want to run this package again, I don't have to open ROS core. I don't have to run the ROS node command. Just open up the ROS launch file using ROS launch, name of the package, name of the launch file. It will probably not work, but it worked. I should have installed the package using catkin make first, but because I didn't change the code much, it worked. Now the nodes are running. I didn't even have to type the ROS run command. To check it, ROS node list. There are two nodes running. Node 1, I called it publisher, node 2 subscriber. Look at the topics. ROS topic list. There is a data topic and it's running from node 1, which I defined in the launch file. You can echo to see what's inside it. ROS this is the data inside it, that sinusoidal function. Because I didn't run the nodes independently, nothing was showed up. It was just running all the nodes at the same time without even using the ROS run command. So in the end, when you build a package, you have your Python code, you can build the launch file to run all of them at the same time. So potentially now you are ready to work with ROS, you know all the essentials, how to build a node using Python, how to communicate to other nodes over a topic, and you will practice this in the lab practicals.